Alright, so tonight we're going to look at factoring completely and solving polynomials. Equations. Alright, so we've already looked at factoring difference of squares. Basically, whenever we see a square and a minus sign with it, we check to make sure that we have perfect squares, and then we factor x minus y, x plus y. Then we have the difference of cubes. For our difference of cubes now, you got a 3 instead of a 2. You factor. We take the cube root. That's our little song that we came up with. You take the cube root of x cubed, you get x. The cube root of negative y cubed, you get negative y. This becomes our first term. And I guess I'll put a little note over here. First. And this is our last. So then you square the first term. Multiply the two together and change the sign. And then you square the last term. So negative y squared becomes y squared. There's your factors. Then we have the sum of cubes. Which is the same thing, except for now we have a plus sign. So we basically do the same thing. Cube everything. Then we square the first term. Multiply the two together and change the sign. Square the last term. This is just a recap. Now, the biggest problem that I kept seeing was when we had to factor out our GCF. When we had to factor out our GCF here. So we want to make sure that we remove all common factors, which is basically our GCF. Okay. So if we look at an example of this, we have 2x cubed plus 2x squared minus 6x. We look at our problem and see what our GCF is, which is the greatest common factor, the factor that every problem has, or every term in our problem has. So if we look here, this has a 2, this has a 2, and this has a 6. So that means 2 can go into everything including the 6. So that means we have to divide by 2. But I have an x cubed, an x squared, and an x. So the common is going to be x. So you got to divide by x as well. When you do that, you put the 2x on the outside, and then 2 goes into 2 one time. 3 minus 1 is 2, so you get x to the second. 2 goes into 2, 1. X squared minus 1 is going to give you a plus x, because 2 minus 1 is 1. And remember, all of these have 1, even though we didn't see it there. And the last one is going to be 2 can go into 6 3 times. And x minus 1 minus 1 is 0, so you don't have the x anymore. Alright, so then you want to check, because this is a 3 here, the factors of 3 that would give you 1, there's no factors of 3 that would give you 1, because 3 times 1 is 3, and 3 minus 1 is 2, so this is factored completely. So we're done. That's when you take out your GCF. Let's look at another one. U to the third v plus uv to the third. What is our GCF here? Well, this has 3 u's, this has 1, so I know I got to do 1u. This has 1v, this has 3v, so I got to do 1v. So our GCF here is uv. 3 minus 1 again is going to give you u to the second. 1 minus 1 is 0, so those go away. Same thing with the u's. And so we got 3 minus 1 is going to give me v to the second. And so we're done. Because this is a plus, it's not the difference of squares. So we have to leave it just like this. Okay? So now let's look at factoring polynomials in quadratic form. So this is where it becomes just a little bit tricky. So let's look at the problem 81g to the fourth minus 256. Okay. Well, right off the back, you want to make this, because this is to the fourth power, you want to make it in quadratic, and quadratic is to the second power. So what can we do to raise g to the fourth to the second? We can rewrite the problem. Square root of 81 is 9, so we can say 9g to the second, and all of this can be squared. It's almost like doing a substitution. So we can let u equal 9g to the second. And it just makes it just a little bit easier. We just came up with a number or came up with a variable, and we're going to set u equal to that. So now I can replace this with u to the second minus, and we have 256. Well, we know the square root of 256 is 16. And we can leave it like this. So looking at this problem and looking at this problem right here, this one looks easy, because we know this is the difference of what? Squares. So we can say u minus 16 times u plus 16. And then go back and substitute u in, and we get 9g to the second minus 16 times 9g to the second plus 16. Can't do anything with this because it's a plus. But the 9g to the second minus 16, both of those are perfect squares, which is the difference of squares. Square root of 9 is 3, so we get 3g to the nothing to the 1, and then square root of 16 is 4, so we get 3g minus 4 times 3g plus 4 times, we still got to bring the other one down. So if you do the substitution, it just makes it easier for you to look at the problem and then substitute it back in. I like to do another one like that. So let's look at another example. Okay. Z to the eighth minus 16. Okay. So we're going to pick another variable. You could say, I like to use u all the time. Let u equal u to the, z. Sorry about that. Z to the fourth. Well, why did I know to do z to the fourth? Because remember we said we're going to look for something that's going to be raised to z to the second power. And the only way we can get z to the second power if we rewrite this power. And we learned that first semester. So I can rewrite this as z to the fourth times 2, because when we have a power raised to a power, we multiply. So 4 times 2 is 8. So we're going to let u equal z to the fourth. So now we end up with z to the fourth, and that's squared. So we get u squared minus 16. And you can easily do this. So this is u plus 4 times u minus 4. Remember, it doesn't matter which way you put those in, as long as you have them with the correct sign next to them. So now we're going to go back in and substitute u, and u was z to the fourth. So this is z to the fourth plus 4, z to the fourth minus 4. So now we got to factor this again. We got to factor this. Because z to the fourth is a perfect what? Square. More than 1, isn't it? Because we got 2 of those. Could I have done a bigger number? Not really. That was the only thing I could do. So I got to do another little substitution. Or I can say, keep this. Z to the fourth is z to the second. Difference of squares still. Minus 2. Oh, I'm done here. Plus 2. Because 2 is not a perfect square. So z to the second, because 2 times 2 is still going to give me 4. So this is the final answer. I think that's a lot to take in. I think it's a lot to take in. Okay? So, what you could do tonight is just, or over the weekend, just practice looking at those and converting those particular problems. Let me give you a couple to work with so that you can see how you need to translate those. Let's see what we got here. Just give you 1 or 2 problems to do. Let's do z to the 10th minus 81. And number 2, then you can do 49 z to the 12th minus 36. Okay? You guys have a good weekend. Be safe.